Hi everyone, so today we're going to do the first chapter, which is forces. Okay, so what are forces? Okay, let's look at them. So today we're going to cover two things. What is a force? And then we're going to look at balanced and unbalanced forces. Okay, so what are forces? Okay, so a force can be a push, it can be a pull. Okay, for example, when you push open a door, you apply a force to the door. So you push the door. Or let's say you want to open a drawer, so you pull open a drawer. So it's a push or a pull. Okay, so you cannot see a force. Okay, like you cannot like when you're pushing the door, you cannot see the force that you're using to push, but you can see the effect of the force. So the effect is when you pull the door will open. Okay, so the effect of pulling the door is the door opens. So we don't see the force, but we can see what the force does. Okay, so we have push, pull, and then twist, for example. So these are all actions that can cause, that involves a type of force that will cause an effect. Okay, so a force is a push or a pull. A force cannot be seen, but you can see how it affects an object. So a force can do three things. It can change the speed of an object, a moving object. So let's say I have a car, a toy car, and it's moving slowly on the floor. And if I push it, it will move faster. Or if I try and block it, it's still a force. It will be slower. Okay, it can change the direction of a moving object. So for example, again, the toy car, I push the toy car and then suddenly instead of going straight, it curves a little bit. So it's changing the direction. And it changes the shape of an object. For example, a plasticine, a ball of plasticine, when you press on it, you push on it, the clay, the plasticine will change its shape. There's a dent. So force can change three things: speed, direction, and shape. Okay. Force can be measured using what we call a force meter. Okay. And the unit of force. Okay. When you measure something using a force meter, for example, when you measure temperature, is degrees Celsius. When you measure force, you use Newton, which is a capital letter N. Okay, so if I measure two things, 100 Newton and 5 Newton, of course the 100 Newton has a bigger force. The 5 Newton is a smaller force. Okay, we can show forces acting on an object using what we call a force diagram. Okay, what is a force diagram? It's a diagram that has the object, moving object or whatever it is, and then it shows you how much force is acting on each, on the right and on the left, or up and down of the object. Okay, and then we have two types of forces, which are balanced forces and unbalanced forces. So when forces are balanced, so this is what happens. So if, let's say I put 2 Newton meters, these are called Newton meters, I pull them equally hard from both sides. So I hook them together, I pull from the right and from the left, and I use the same force. Okay, I pull equally hard. Then the forces recorded on both sides, let's say I use 10 Newton force, both will be equal. So we call balanced forces because the forces are balanced on both sides. They are equal in size, 10 Newton, 10 Newton. So this is a type of force diagram. I have the object and then I have an arrow on the right and on the left stating how much force is acting on each side, and it's both going in opposite direction. That means one side I'm pulling it to the left, 10 Newton, and one side I'm pulling it to the right, 10 Newton as well. So a force diagram is when I draw the object and then I put two arrows, one on the left, one on the right, and I also put how much force, the magnitude of the force on each side. So this is what we call a force diagram. And this is for balanced forces. Both sides are equal. Okay. So when both sides of the force are equal, okay, they cancel each other out. They are equal in magnitude, but they're opposite in direction. One is to the right, one is to the left. Okay, because the forces are balanced, so I'm pulling 10 Newton to the right, 10 Newton to the left. What happens? They cancel each other out, and the hooks in the middle here, they don't move because both also equally strong on both sides, left and right. Okay, so if forces on an object are balanced, an object that is not moving, for example, like the force meter, it will stay still. And let's say an object is moving. Okay, like for example, a car. I'm moving in the same speed, and there are forces on the left and right on the car, but they are all equal in size. That car will continue moving in the same speed and in the same direction. It won't be faster, it won't be slower, it will be in the exact same speed. It will move in the same direction. It won't change direction. Okay. Okay, then I have unbalanced forces. Again, I have the Newton meters. Let's say now on one end, I pull stronger or greater than the other end. Let's say one side is 11 Newton, slightly more, the other side is 10. So they are no longer balanced because one side is bigger than the other. So we say it's unbalanced forces. And what happens is, okay, the force meter will now move. Just now it didn't move, it stayed put because both sides same amount of force. Now the left hand side is slightly more, 1 Newton extra. So what will happen is the force meter, the Newton meter, will move to where the bigger force is. So in this case, the bigger force is in 11 Newton. The Newton meter will move towards the bigger side because it's pulling stronger. When you pull something, when you pull something stronger than another person, let's say you're pulling a string with a friend and your pull is stronger, the string will move to you. So what has happened is the speed has changed. The speed of this Newton meter has changed, and this is what we call acceleration. Okay, so unbalanced forces will lead to a change in speed or direction. So that is all. Thank you guys and see you next week. Bye.